Alright, here we go, graphing this. We get the vertex is going to be negative 4, 1. We know the a value is 2. We know that it's going to be shaded greater than the line, or actually instead of saying greater, let's say above the line, and we know that line is going to be dotted. Okay, so negative 4, 1, and then my a value is 2, so when I go in 1, instead of going up 1, I'm going to go up 2, and then instead of going up 2 and going up 4, 1, 2, 3, 4, I'm going to go up another 4, 1, 2, 3, 4. So actually into up 1, 2, 3, 4, 5, 6, 7, 8. Now, one thing you can do too is you can do the same thing on the other side, or you can just reflect, because you know the axis of symmetry is going to be right down the middle here. So I know I'm going to have points equidistant from the axis of symmetry. So I have another point here, and then my graph opens up, and then it's y is greater than, so then I'm going to shade above the line. And then to get the y-intercept, I know that x is going to be 0 to get what y is. So then this is going to be, whoopsie, this is going to be y equals 2 times 0 plus 4 squared plus 1. 4 squared is 16. 16 times 2 is 32 plus 1, which is 33. So my y-intercept is at 0, 33, which this graph right here, it's not appropriate to graph that. Sometimes we can do it quickly, but obviously at 33, and then this graph is at 10, that's way up there. And then we want to get the x-intercepts. Now, I know there are no x-intercepts, but I want to get, let's say if I wanted to get the roots, and I know my roots are going to be, I'm going to have imaginary solutions for my roots. I could find those. If I plug this in, I'm going to get 0 equals 2 x plus 4 squared plus 1. Subtract 1, so I get minus 1 equals 2 times x plus 4 squared. Divide by 2, so now I'm going to get negative 1.5, or negative 1 half equals x plus 4 squared. Then I'm going to take the square root of both sides. Okay, and so then I get the absolute value of x plus 4 equals I, and then this ends up being root 2 over 2, and then this is going to be x plus 4 equals plus or minus I root 2 over 2, and so this will be x equals negative 4 plus or minus I root 2 over 2. And so that is my, not my x-intercepts, but that is my roots if I wanted when the function was equal to 0. So because I'm getting I, this tells me that I don't have any x-intercepts, so no x-intercepts. And obviously we can also tell this from the graph, but I thought it was important to kind of plug it in and then see what you get, and realize when you don't cross the x-axis, you better get an imaginary number in your solution.